In this video, I'd like to talk about the concept of multiplying decimal numbers. So we have this example here, 5 times 3.4. And for this first example, I'll just walk you through the process for how you actually compute this. And then I'll try and make sense of it by explaining at least how I think about why we follow this certain process. So the process, we're just going to line up 3.4 times 5 and multiply as normal, and we're going to ignore the decimal when we start. And then at the end, we will count up how many decimals we had in our product and just add that amount of decimals to our final answer. So we'll just multiply this normally. 5 times 4 is 20, so you put a 0 there, put the 2 up here. 5 times 3 is 15, plus 2 gives you 17. And then at the end of this problem, you want to count up how many total decimal places you had in each of these factors. So you just had 1 there, and you had none there. So in total, you had 1 decimal. So you go to your answer, you start all the way on the right, and we'll just go 1 decimal place over. So this becomes 17.0. Now, you might be wondering, why do we do this process? How do we know for sure that this is the right answer? Well, you could think of it with normal multiplication. This is like adding 5 3.4 times, which is a little bit awkward. We can add it 3 times, no problem, but then adding 5.4 times doesn't quite make that much sense yet. However, you could reverse it. This is the same thing as adding 3.4 5 times. So if you did 3.4 plus 3.4 and so on, you do it a total of 5 times, you would get back this 17. And in this case, you can just actually add those. So that's one way to think about it. But if they're both decimals, that way of thinking about it doesn't really work. You end up with that idea of adding a number a fractional amount of times. So another way to think about this, to make sense of this type of problem, is to essentially just rephrase the problem. So 5 times 3.4 is the same thing as 5 times 34 over 10. Because essentially you have 34 tenths here. We can just divide everything by 10, and these are equivalent. Remember, division by 10 just moves the decimal one place to the left. So we can do it in reverse, write this as 34 over 10, and then we can just do 5 times 34, and then at the end divide everything by 10. 5 times 34 is 170. Dividing that by 10 does give you 17. So you still get the same answer, and notice in the process, we just multiplied those numbers, 5 and 34, ignoring the decimal. And at the very end, we divided by 10 to essentially put that decimal place in. So this is one way to think about it, and you can apply this to really any of these problems, at least to understand why this process works. Because you don't want to just blindly memorize multiplying these decimals that you ignore the decimal, count up all the decimal places at the end, and then add them to your answer. You don't want to just memorize that. You want to understand it so that way you're much more likely to remember it. So let's look at a couple more problems. Let's say we have 7.3 times 8.6. So we'll go through the same process. Remember, we're just going to multiply these, ignoring the decimals, and then at the end, we'll count up our decimal places and add that to our final answer. So 6 and 3, that's 18, and carry the 1. 6 and 7 is 42, plus 1 gives you 43. Then you put a 0 down there as you move one place over. 8 and 3 makes 24, so we put a 2 up here. 8 and 7 is 56, plus 2 gives you 58. Now we add down the columns, so 8, 7, this is 12, carry the 1, gives you a 6. And notice we had 1 decimal place there and 1 decimal place there. So we start all the way to the right, and we go 2 places over to the left. So this is going to be equal to 62.78. And you can get a rough approximation for what your answer should be, just so that you're at least in the ballpark with your order of magnitude. Notice that this is about 7, and this is about 9, and 7 times 9 is 63. So this is pretty close to what you'd expect. Now, if we had an answer like 627, you would know that you did it wrong. or even if you had an answer like 6.278. Again, you're an order of magnitude off then, and at least you know that you made some mistake. Now, this won't give you an exact answer, and it's not a direct way to check your work, but at least will give you some intuition that you're doing it correctly. So let's again make sense of this method, though, because like I mentioned before, we don't want to just blindly memorize putting it into columns, multiplying by ignoring the decimals, and then just counting up the places and adding that to the answer. So 7.3 you could think of as 73 tenths, and we're multiplying this by 8.6, which you could also think of as 86 tenths. So really, we're just multiplying 73 by 86, and at the end, dividing by 100. But notice that's exactly what we did here. We multiplied, ignoring the decimals, 73 times 86. We get this 6,278. And at the end, we divide by 100 because there's 2 decimal places. And this division by 100 takes that into account. Dividing by 100 just moves the decimal twice. So you still get this 62.78. It's just a different way of thinking about it. So let's keep going. Let's do another big example. And I'm just going to put it straight into columns. Let's say we have 41.73, and we're going to multiply that by 8.641. So lots of numbers this time. We should end up with a pretty big decimal answer. But if you just start by counting the decimal places, you have 2 there, and you have 3 there. So in the end, we'd expect an answer with 5 decimal places. And remember, the other way to think about it, you could write this instead of 41.73, you can write it as 4173 all divided by 100. Because notice, to move it 2 decimal places the other way, you have to include this division by 100. To move it 1 decimal place, you just divide by 10. And then this one, so we'll multiply it by 8,641. We had to move it 3 times, so this will be divided by 1,000. So in essence, we're multiplying these 2 big numbers, 4173 times 8641, and then dividing by 100 times 1,000, or that's a 1 followed by 5 zeros. So we're, in the end, you're going to be dividing by 100,000, which will move the decimal 5 places. So let's just quickly go through this. 1 times anything is itself, so I'll just rewrite that top line, and then we make a 0. Now 4 times all of this, 4 times 3 is 12. 4 times 7 is 28, so we put a 9, carry the 2. 4 plus 2 is 6. 4 times 4 is 16. Now we move to the 6. We put 2 zeros. 6 and 3 make 18. Carry the 1. That's 42, 43. Carry up the 4. 6 and 1 plus 4 makes 10, so a 0 plus a 1. And 6 and 4 make 24. Plus 1 is 25. Actually, I forgot. We've got one more row. We've got to go with the 8. So we put 3 zeros because we're now 3 places over. 8 and 3 is 24. So this becomes a 2. That's 56 plus 2 is 58. Put a 5 up there. 8 plus 5 is 13. Put a 1 here. That's 32, 33. And now we add. So that's 3. That's 9. This is 18. We put a 1 up there. So that's 10, 11. Plus 7 gives us 18. And 7 plus 8 is 15. Carry the 1. 2 plus 8 is 10. Carry the 1. That's 6 and 3. And now we move the decimal 5 times. So 1, 1, 2, 3, 4, 5. It goes right there. Just double check. 1, 2, 3, 4, 5 after the decimal. So we get that final answer of 360.58893. And we can get a rough idea if this is at least in the ballpark, because we're essentially multiplying somewhere around 40 times somewhere around 8. Now this is going to be too low because we rounded down in both of these. So you could also do maybe 42 times 9 if you want to get an even better approximation. But this is about 320, which, like I said, will be a little bit lower than the actual answer. So we did at least get in the right order of magnitude. And ultimately, you'd have to check this with a calculator. Now, you want to be able to do this by hand. You don't want to rely on the calculator to do these for you. You want to understand it, rather than just memorizing the process.